Welcome everyone to today's live stream here. A little bit continuation of my secondary live stream, more live random stuff with me in case you're interested in that. I was curious about these compilers we benchmarked because obviously I mentioned it a couple of times, not only all the other software that gets slow, also the GNU C compiler collection there, GCC. Compile times get longer and longer, and we looked already into CLang for that, LLVM CLang, that unfortunately did not yield the performance improvements that we were looking for. And I continued on this a little bit just to finish here this round of compiler benchmarking in 2019, because beside GCC and CLang or Clang from LLVM that you might have heard about, there are also a couple of others that you might never heard about. One is TCC, a tiny C compiler from Ballard, who also wrote QEMU and some other fun stuff. And what is his first name? Fabrice Ballard or something. And he also wrote, actually started FFmpeg, QEMU, and other stuff like even JavaScript, Linux in a browser and fun stuff like this. But yeah, tiny C compiler, I guess this came out of a obfuscated C competition he participated in, I think. At least this is what I remember. But also, as so many projects from him, he probably often lost interest, can't earn money with this or something, and he is not continuing this. So a couple of other volunteers took over this and still maintain this. But even so, from this alternative compilers, maybe TCC, this tiny C compiler, is the most active. And they write here compilation speed measured here with the Lynx text browser project, 76,936 lines, including headers is 67.2 megabyte. And here they measure against the super old version of GCC. Even this was back in the day 20 times or no, 9 times faster. And you see GCC is or was actually 3.2, right? So GCC, even back in the day when I said this was still fast, I mean today, whatever. Anyway, so back in the day, GCC was processing these sources at 3.4 megabyte per second on some, whatever this was here, Pentium 4 or whatnot, here 2.4 gigahertz Pentium 4, and TinyCC at a whopping 29 megabyte per second, which is of course amazing. And I remember back in the day that there was some special project of him that you could run. I think this was probably user mode Linux. So you could, with a patched version of Linux in this user mode Linux, instantly boot Linux here or boot run Linux here in TCC, because actually, fun fact of TCC, you can write this in kind of shell script. So this #bang and then /bin or env TCC and run your C programs like shell scripts or other interpreted languages, fun stuff. Interesting thing in case of, and also you can obviously, well, not obviously, but you can link this into your program if you want something that is scripting in C. You can use TinyC with libtcc or something and dynamically compile and run code there in your project if you wanted to do that. And yeah, they're still developing this, and in the meantime I think they support x86, AMD 64 and ARM, maybe even ARM 64 or something, but not more. And also you see the development, the last release here was already from also quite some time ago. Anyway, I will show you benchmark. I benchmarked this obviously, otherwise there would not be much point of a video. It's just a quick summary. And then there's also PCC, some portable C compiler that was actually initially coming out of, was it Berkeley or something? And their goal is to write a C99 compiler here, while still keeping it small and simple, fast and understandable. And it's not affiliated with any other project, but the compiler has been imported into OpenBSD, NetBSD, and maintained by this one, me, Reg or whatever. And what the product includes software development owned by Caldera International. Okay, anyway. And so yeah, maybe this was used at some point in OpenBSD or something. If I don't mix this, that they wanted some BSD licensed compile or something, is by the way PCC history, portable compiler from Stephen C. Johnson, written in the 70s, and Unix version 7, blah blah blah, and so on. And last but not least, Degraver, thank you for updating us on the date. So it's only 1.5 years, December 17th, 2017, 18. So yeah, 1.5 years, but I wish anyway they would release slightly more often. And I tested this and I have some final words, but last but not least there's also NWCC from Niels Weller, who I met also back in the day with this compiler MIPS and Linux T2 fun, with our one-man T2 distribution, also from people you meet on the way. And it also looks a little bit that he probably has other fun things to do in life, because he did not update this in 4 years or something, I think. And they even mention here T2, nice from them. And they have a version table. Let's see. Yeah, so they support a little bit more like Spark MIPS and PowerPC, but not that this would be the most feature complete, that we will see in a moment. And where are the releases? This was probably 5 years or even more on this SourceForge page. Oh, it's also. Anyway, coming to the results, I can tell you, to my surprise, I expected this PCC that I previously never really used. I tested NVCC also probably on MIPS, PowerPC and Spark for Niels, a couple of 5, if not 10 years ago or something. And yes, so this is from 2014. Just a little bit, getting a little bit old, but you see 10 downloads this week or something. And from all the compilers, I have to say that PCC, I expected PCC to be the most feature complete, but actually I compiled it, it didn't work. Did not even on 32-bit, it did not even compile. You can watch my previous second channel if you're interested in that detail. Always surprises me a little bit, 30, 40, 50-year-old product, but it's 770, so yeah, over 40 years maybe. And then in 2019, you run make install, and this thing doesn't even work. And yeah, then I packaged there also PCC libs and hacked a little bit in the headers, because initially I thought I make this video without even PCC results, but then I thought, no, this is too lame, even for my standards here. So I spent a couple of extra hours to hack a little bit around there to make this PCC at least work slightly, a little bit for me. But coming to the results here, long story short, these are the results. And you see here on the list, so this is all the previous results from the CLang experiments, also with set for more size optimization there. And you see here are quite some gaps. This means, well, initially the PCC line was completely empty. The 3 results I have only because I hacked around on this stuff to even work at all for me. And yeah, even then it didn't compile everything. And so I have to say, I think TCC and NWCC, they just worked like you would expect. PCC, I had to hack around an hour. And then you see, even then, it did not build everything. However, TCC, probably you have seen NWCC, not really much developed. But what I wanted to show you is, this is of course the runtime of the programs. Maybe let's take one step back and take a look at the build time. And here you see how fast compilers can be if you don't feature load them as much as GCC and CLang. And yeah, so this is the build time of this individual projects, bzip2 and gzip, so unsurprisingly compiled by everything. You also see how whopping fast here TCC is, even set standard, probably. But you also see NWCC also compiles here rather fast, but certainly a little bit more advanced C code that gets here optimizing compilers to think 20 times longer here on this. But if you compare this, one of the slower runs, if you say 20 seconds here for the larger optimizing ones, and compare 20 seconds to 17 or to 0.17 seconds, then wow. But of course, all of this compilers, from all of this compilers, that you learn something here from this video, only PCC is optimizing, that you will see in a minute also again from the runtime. So this is a build time, what only developers like us are interested in when you test compile either your own project or TCC or Linux or something. And so from all of this, NWCC is not really optimizing, and TCC also not really. And this also explains why this is so whoppingly, extremely, amazingly fast. And I do not even say that GCC and CLang with all the optimizations need to be that fast, But hey, a little bit faster than as slow as it became the last years would be certainly nice. But you also see PCC is a little bit optimizing, and it is not the slowest there. As you see also, yeah, maybe twice as fast here sometimes. Anyway, you also should not keep in mind that this is from an AMD Ryzen 16 thread AMD Ryzen here. So this also explains why these build times are so fast. But even, as I said, with 20 seconds, I build each of those sets 2 times, sometimes even 3. For example, some runtime things are run first to warm the caches. So even this thing takes an afternoon to compile all these permutations here of all this stuff. So just that you have some indication here, certainly TCC as fast as optimized and as slow as GCC has become certainly today faster than 9 times faster than GCC. Looking at the runtime, you see that NWCC, something that is not optimizing here at all, is really slow, especially on this really fancy CodeLab set standard. This is, yes, it's compiling faster, but the resulting binary is 3 times slower than even the slowest unoptimized CLang and GCC versions. There you see really the difference of optimizing compilers. Obviously, means they better spend the CPU cycles to optimize something. But even for, yeah, unfortunately here we don't have a result because PCC, but yeah, a little bit optimizing, I think, as far as I read in the documentation. So PCC is not as slow, the Portable C compiler, and TCC, of course, as it is not optimizing very much, it is as slow as unoptimized, completely unoptimized O0 code here from CLang and stuff. No surprise there. I wonder a little bit that this directly running Linux did not catch up here. Was a fun thing to do. Maybe something, if you develop really on virtual machine stuff, maybe this would be a really nice setup to directly run the Linux kernel executed in TCC. Fun stuff, maybe another live stream, another month I resurrect this experience. But there you have it, even more compiler benchmarks just for your general idea there. I probably will try to go a little bit supporting CLang more, especially the CLang Musl here for a GCC-less systems to potentially, yes, it is not really that much faster, but again, after I found OZ here, this OZ actually was slightly faster here build time wise. OZ for more size optimization is at least a little bit faster than OS and O2, at least as far as I remember, yeah, 0.9, 0.7. So some 15% or something, depending on what you're compiling. So probably personally, I will try to switch a little bit to CLang just for the fun of it. Also, there's always something that you can do to make your source distribution even more amazing. And for this, of course, testing all this, because this means you have seen there are still, what was it, 30 or so build errors, even in the minimal set. Besides that, with Musl, the alternative C library, even Valgrind still segmentation faults, and what else I will find there. And yeah, so as I said, not the most amazing, outstanding performance, but for my portable Votor is awesome virtual machine. But this is also what I make these YouTube videos for, because even in this video, not only have I updated PCC and T2 because it was not, why should it still compile, right? I set this in this alternative secondary channel of mine. I had this latest PCC update from whenever that was laying around there on the build server, because this kind of not really used packages don't interest me that much. So this YouTube video here today, you're sharing and liking and subscribing, has financed and helped here updating PCC, packaging PCC libs, because there's some additional runtime stuff, and I think even it came with some headers. And yeah, so one package updated, one package added, and also fixed because PCC, as seen in my other live stream, was not compiling due to naive and strange typos in the ifdefs for multilib. So some stuff done here today, and some benchmarking and education of alternative packages. Of course, missing in this list is at least Intel compiler. There's also some other, there's some open AMD forked something, some open whatever something. And there are also theoretically other commercial compilers that I constantly forget because I'm not really that interested in commercial compilers. Maybe OpenPath or whatever. Maybe leave in the comments below what you tested. Not really sure. Probably Intel still updates their ICC, the Intel compiler, maybe not, that at least previously Intel marketed as to optimize even more. Also worth noting, I think none of these compilers probably has switches for optimizing for specific architecture. So I think you can, as far as I remember and see, maybe TCC, but not NWCC and PCC. I think they can probably not optimize for Core 2 versus latest, so greatest latest AMD family 10, Zen, whatever, Core i7, and also not support obviously fancy single instruction multiple data like MMX, SSE, AVX, and other fun stuff like this. I hope you learned something from this overview and got some inspiration of what to do, to use, and how this fits together in the world of computing, what compiler do, how they at least spend the CPU cycles in terms of optimizing. The Graver writes, comment in the audience, good you mentioned runtime versus compile time. I think end users are more interested in faster runtime. Yeah, this is just, of course, my use case, slightly biased here, compiling whole distributions from scratch. But if this each other year you update your fancy build server and your CPU cycles are eaten away by the latest and greatest compilers, spending more CPU cycles to optimize your binary just for very little outcome. Often I probably should add here more benchmarks so that we maybe have libjpeg or something. By the way, this benchmarks, I disabled assembler optimizations because in my opinion this is unfair. Some, for example, GNU-PG or something, maybe even libmet has support for handwritten assembler optimizations, and even a decade or 2005 or when this was, I was so clever because back in the day I wanted to benchmark various GCC versions. So in this open bench of mine here since 2005, I run this like in the spec benchmark with assembly stuff disabled, because it would be unfair if all the CPU cycles in MP3 encoding or encryption are spent in hand optimized assembler. Doesn't make much sense. Of course, so you can of course have faster GNU-PG with assembly optimizations enabled, but this is not the point of this benchmark. And also, by the way, this is also something that you need to keep in mind if you will read others' magazines, articles. Some magazines and news sites are not as careful in pointing out if assembly optimizations are used or not, because certainly this is not the compiler if you have handwritten assembly there for single instruction multiple data. More comments in the audience. The Graver, Intel C compiler, it appears open source contributors can get a free license. Actually, so from a Linux magazine article, I have a completely, theoretically, I have a license code for the 2005 edition, though probably that's not worth much anymore. And theoretically, Rock Linux, aka T2, had support for ICC, though most people never used it, and probably no one has touched this script glue in a decade or two, so whatever that works, I don't know. But again, I did so much, it's probably a little bit hearable in my commentary here, that after 20 years, this is also why, by the way, I started this YouTube channel, to have a little bit more relaxing talk here, instead of just sitting in a basement or wherever and doing open source maintenance stuff for 20 years. So this is also sharing here some results. If I would just do this here on my own, it's of course nicer to share those results on YouTube. And then with this, as I said, with microkernel, and I actually have a Voodoo 2 arriving here, so I probably should now also spend the night to hack some bare metal Voodoo 2 acceleration code there for the next bare metal 3D fun. And then I probably really will do some more microkernel stuff, because I'm really curious to write some multi-server microkernel stuff, just to do some more advanced research and development. Again, because I'm slightly tired of 20 years of packaging other people packets and trying to hotfix them, because like PCC or other stuff not even just working out of the box. Although, of course, as usual, at the end of the live stream, we have the most people in the audience. I guess it is time to call it a day, because otherwise people don't watch the super long live streams. And as a related note, I probably will, for the next weeks to come, try to keep this weekly IT news at 1 hour maximum, just for hopefully more people to enjoy it more. Probably makes no sense to talk so long and then nobody wants to watch it. So yeah, always trying to also optimize this video content for the greatest viewing pleasure and use of your and my time. More comments in the audience. Maybe you already mentioned it, but have you looked at Google's Fuchsia? No, I've not looked at this. A decade ago or 15 years ago, I looked at L4 microkernels. Not done that much with that. And yeah, Fuchsia, I've seen it. There is also other stuff. Microsoft even did something, some barrel fish or what that was. Maybe we can, Microsoft also has some other projects sometimes. There was Microsoft Barrelfish or something, whatever that was, a Barrelfish operating system. So there's lots of operating system research that most people don't know about. And of course, I could sit here like other people in the university, like some professor, and in silence. Of course, it is slightly vaporware, but at least, hey, I have some 3D, bare metal 3D demos on the S3 Verge to show. Not entirely vaporware. That I said this, why have I done this? When back in the day I could not get this to work with our limited knowledge of hardware when we were 16. Well, limited knowledge. We could do VGA programming and Sound Blaster programming and such, just not enough at the age of 18 or 15 or so for protected mode initialization and debugging. But this is why I nowadays wanted to have this S3 Verge, as I've shown that I have the printed paper data book there, which in my opinion also all silicon manufacturers should actually release, like NVIDIA. And so not entirely vaporware, and I will continue, and this is why the way I will, as I said, I will, independently of any microkernel idea, my latest idea that I want to go forward there on the roadmap is to have single header, because I really like this idea of single header libraries. So I will try to make single header files like functions, support functions for IDE, for SCSI, for VGA, of course, we have this already, for S3 Verge, for even Voodoo, because hopefully this card arrives in a working condition so that we can have fun with it. And then also other people can use it for their hobby demo or new vintage games there or retro games on DOS, independently of my microkernel. That I think, in my opinion, could be an amazing, useful resource to share. And then this could be building blocks for not only research and development, because I will not just sit here and write an amazing kernel here from scratch. This will take a year or two with experimentation. So this is why I think this is, in my opinion, maybe hopefully amazing idea to have this code fragments to share and to combine. Then I can make several examples with this shared header files, self-contained header files, and make the experiments, benchmarks, multi-server stuff, context switching, parsing, IDE, SCSI, packages around there, with different kinds of optimization strategies to avoid context switches and throughput and even 3D. This is also why I get the Voodoo card. Why do I care about these vintage cards? Because they are easy to program, and in contrast to latest NVIDIA Silicon or P3, AMD, you name it, the AMD driver certainly has 100,000 lines of code. And with this 3D S3 Verge and 3DFX, 3DFX Voodoo, you can with just 100 lines of code draw shaded and textured triangles. And this is why I will, although this is vintage, it is to draft and experiment research and do performance testing and get some stuff running. In my opinion, an amazing thing, even partially usable in emulators, PCM or QEMU, though with yesterday's or the day before yesterday's Rock Linux live stream, we also found some bugs in the Cyrus emulation there on QEMU, in case someone wants to have some fame and look into that. And Google is that serious. I'm not so, maybe. The problem is with this Google thing is that the thing is, Google is in some ways fast moving, but not with their cash cows. So you see this in this AdSense, they don't do many changes. And even with YouTube, this is something sometimes really old-fashioned, especially this AdSense is really, they have not even updated the AdSense management interface here for a decade or something, only recently a little bit. And anyway, so this might be a failsafe, but I would be surprised if this is coming that soon. Though, of course, they can reuse the runtime, but yeah, time will show, of course. But this also the problem is with vendors, maybe vendors like Samsung and Huawei and such, maybe the vendors themselves need a fallback, not to be as dependent on Google there, on licensing details and such. So I think Huawei and Samsung both probably have said already that they have some alternatives in-house. And by the way, at least Samsung, as far as I remember, not only did they not buy something related to open source, but in any case they employ, since a couple of years, I think they employ the Rasterman of Enlightened Man fame, and he's some Samsung, Google something, the Rasterman. Those people who are 20 years in Linux like myself, Rasterman. He is Enlightenment. Raster, also best not misspelled. And as far as I know, Mesa assembly bug in something. As far as I know, he works for Samsung for probably already 10 years. Unless he has a new position, whatever. You probably mind. Anyway, so he was also back in the day, he was at Red Hat. And then he eventually left Red Hat for something. And at least 10 years ago, he was at my contact information at the bottom of the page, whatever, at least 10 years ago, as far as I remember, he was at Samsung. Not sure if he still is there. And maybe something even used Enlightenment libraries there, this Enlightenment 17, Canvas and Window Manager stuff, maybe for some smartwatch or something like that. Yeah, that's it for today, I would say. But yes, we can also look at this, and this is what makes this YouTube channel so much more fun. Instead of just looking at this myself, we can also make videos about this, looking at not only Fuchsia or Fuchsia, Zircon, L4, maybe even Barrelfish. And there's even other stuff, for example, was it this tab or maybe not? There was also, so this was this, whatever that was. By the way, this was even done in cooperation with the ETH Zurich, the ETH Zurich, and actually they have here some new release. That is interesting. GitHack here. So yeah, actually they really work on this. That is nice. It's new research. Let's see, what was the summary? Future multi and many core systems, close related trends, hardware design, rapidly growing number of cores, scalability challenges, exploit, yeah, something. And also Haiku, other people ask already. I had Haiku obviously on my to-do list. Fun fact, the Haiku people, before, when they were, I think they were still OpenBOS a decade ago, and in the BOS times, I think around 2005 or something, they even asked us if we are interested in doing the package management with T2. In retrospect, I should probably have been more engaged with that. That would, of course, have been a cool thing if T2 would have been the default source build package managing thing there for OpenBOS, nowadays known as Haiku. But yeah, opportunities lost. Maybe it would not have been the most matching thing, although in theory we are interested, but my time is limited. But yeah, this is probably one of our big historic mistakes. It would have been fun. Anyway, I hope you learned something in terms of this compiler benchmark. I hope if you are interested in this kind of stuff, this helps you in one way or another. Also, maybe if you are even running Gentoo and are interested in what kind of compiler optimization switches here are the most useful for you. And also, fun fact, if you run this stuff on Transmeter, is my microphone cable long enough? Maybe not. If you run stuff on Transmeter as documented, at least in previous times, here is a Transmeter Crusoe and Efficient there in form of the thin clients that I've shown already on Transmeter code morphing CPUs. It is most highest performance as far as I remember and documented in Gentoo eFlex wikis, at least, unless they have recently deleted it in some cleanup operation to compile with stack and function alignments without any padding, without any alignment, because then the stuff is more compact in memory in the cache and the code morphing software will code morph it anyway to very large instruction words. So yeah, all other CPUs are more happy with, for example, dword or something aligned functions and stack and such, just not the transmitter CPUs. They don't care, the code morphing doesn't care about these alignments. So fun fact at the end, I hope you learned something. Hope to see you soon for the next videos. 0 drop frames thanks to SSH tunnel. Well done Vodafone, at least our SSH tunnel survives this here. With what bitrate do we even stream? 10 Mbit, outgoing 0 drop frames, open SSH to the rescue. Root is saying good to whatever, I hope to 0 drop frames or anything of the compiler stuff. And yeah, then I would say till next time.